Hello everyone. In this lecture, we will discuss the example problem on inventory model with shortage. Let's see the problem. A dealer supplies you the following information with regard to a product that he deals in: annual demand 10,000 units, ordering cost 10 rupees per order, price 20 rupees per unit inventory, carrying cost 20% of the value of the inventory per year. The dealer is considering the possibility of allowing some back order to occur. He has estimated that the annual cost of back ordering will be 25% of the value of inventory. So next we have to determine the first one is the what should be the optimum number of orders of the product he should buy in one lot. What quantity of the product should be allowed to be back ordered, if any. Next, the third one is the what would be the maximum quantity of inventory at any time of the year. So next to last one is the would you recommend it to allow the back ordering? If so, what would be the annual cost saving by adopting the policy of back ordering? So first we have to write down the given data. So that is here it is given. The first one is the annual demand is given. So I have to write down the data. So with general notations, that is the annual demand is the capital D 10,000 units. Next, ordering cost. So 10 rupees per order, that is the C naught, 10 rupees per order, and price is given, that is the capital C, 20 rupees per unit, and it is given the inventory carrying cost, that is the 20% of the value of the inventory per year. So it will be CH equal to the R into C. Here R equal to the 20%, which means 0.2 into C. Capital C is given the 20. 0.2 into 20, it will become CH will become the 4 rupees per unit per year. And dealer, and next is it is given that one the annual cost of back ordering. So it is the shortage cost, that is the CS, 25% of value of the inventory, which is R into C. R equal to the here 0.25, and the capital C is the 20. So it will be 0.25 into 20, it will become the 5 rupees per unit per year. So let's see the problem. So first we have to determine the what should be the optimum number of units of the product he should buy in one lot. Here I have to determine the optimal batch quantity, that is the Q star, when the shortage is not allowed and the shortage is allowed. So first one, when stockouts are not permitted. So shortage is not allowed. So that is the model 1A. So in this one we know the EOQ formula, that is the Q star equal to the root of 2D C naught by CH. Here we know the D value we know, C naught value also we know, CH value also we know. Substitute all the values in the Q star formula. So we will get the EOQ is the 223.6 units. Next we have to determine the optimal batch quantity when the shortage is allowed. For this one, we know the EOQ formula, that is the Q star equal to the root of 2D C naught by CH into CH plus CS divided by CS. Here we know the D value, C naught value, CH value. Moreover, we know the CS value also. Then I have to substitute all the values in the Q star equation. Then we will get the, so Q star when the shortage is allowed, that the Q star equal to the 300 units. Next we have to determine the what quantity of the product should be allowed to be back ordered. So which is nothing but we have to determine the shortage. What is the maximum shortage? That is the optimal shortage we have to determine, that is the R star. So we know the formula for the R star equal to Q star into CH by CH plus CS. Here Q star we have to consider the value is optimal batch quantity when the shortage is allowed, that is the 300. So here Q star equal to 300, CH value 4 rupees and the CS value is the 5 rupees. Substitute all the values in the R star equation, we will get the R star equal to the 133 units. Next we have to determine the what would be the maximum quantity of inventory at any time of the year. So here I have to determine the optimal quantity of the stock in the inventory, that is the M star. We know the M star formula, that is the Q star minus S star. We know the Q star, that is the 300. So here Q star we have to consider when the shortage is allowed. For this one we get the Q star is the 300. S star is the 137. Then M star will become the 167. So next last one is the would you recommend it to allow the back ordering. For this one we have to compare the total variable cost with shortage and the without shortage. First we have to see the total variable cost when shortage is not allowed. So total variable cost at the Q star without shortage, we know Q star value is the 223.6 quantity. So we know the equation for the total variable cost without shortage, that is the model 1A. We already discussed the equation for this one, that is the root of 2D C0 CH. We know the D value, C0 value, CH. Then have to substitute, we will get the total variable cost is equal to 894.43 rupees. Value we get in the rupees. So next we have to determine the total variable cost. So here at the 300. Yeah. So total variable cost when the shortage is allowed. So when the shortage is allowed, we are getting the Q star equal to the 300 units. So here it is to be wrong. So we know the already we discussed. So total variable cost when the shortage is allowed, that is the formula is the root of 2D C0 CH into the CS by CH plus CS. We know all the values, D value, C0 value, CH value and also CS value. Then we have to substitute, we will get the 666.67 rupees. Here compare the cost with shortage and the without shortage. So shortage is allowed, it is reducing the variable cost compared with the shortage is not allowed. Then the question is asking, would you recommend it to allow the back ordering? Yes, we have to allow the shortage. So this is the solution for the given problem. Here we have to allow the shortage. So just have to compare the cost without shortage and with shortage. Here with shortage we are getting the less cost in the total variable cost. Then we have to recommend it for the back ordering or recommended for the shortage. Thank you.